Welcome to our latest video on the topic of carboxylic acids, nomenclature and preparation. This video is suitable for A-level students. By the end of this video lesson, you should be able to recognize a carboxylic acid functional group in a molecule and be able to name carboxylic acids using the IUPAC system. You should also be able to describe how carboxylic acids can be prepared from primary alcohols, aldehydes, nitriles, esters and acid chlorides. And finally, you should be able to explain how benzoic acid can be prepared from methylbenzene in an alkaline oxidation reaction. So carboxylic acids are compounds that contain a COOH functional group, and many carboxylic acids are familiar substances. For example, ethanoic acid is found in vinegar. Citric acid is found in lemons, and malic acid is found in apples. Now, ethanoic acid has the following displayed formula. It has a CH3 attached to a C double bond O and an OH. Now, ethanoic acid, like all carboxylic acids, are weak acids, and weak acids are substances that when you put them in water, they partially split up into H+ ions. Now, many carboxylic acids occur naturally. The simplest carboxylic acid is methanoic acid, HCOOH, and this is produced by ants. Lactic acid is a more complex carboxylic acid and is formed when milk ferments, and this is used for the production of yogurt. And lactic acid also found in muscles when exercising. Now, carboxylic acids are named according to the IUPAC system, and the following rules are in place for naming carboxylic acids. First of all, you have to select the longest carbon chain containing the COOH group, and then you derive the parent name by replacing the E ending of the alkane with oic acid. So, for example, ethane is a 2-carbon alkane. A 2-carbon carboxylic acid is ethanoic acid. Now, the carbon atom of the carboxyl group, the C double bond O, is usually carbon number 1 in terms of naming carboxylic acids. Now, the longest chain must contain the COOH group, and the carbon atom of the carboxyl group, the C double bond O, is usually carbon number 1 in terms of naming the molecules. Now, you need to number the substituents according to their position on the chain and write the name listing the substituents in alphabetical order. So an example of a carboxylic acid is shown here. Now, there is 3 carbons in the longest chain. So this carboxylic acid is propanoic acid. The carbon number 1 is the C double bond O OH. So therefore the bromine is on carbon 3. And there are 2 methyl groups on carbon 2. So this compound is called 3-bromo 2,2-dimethyl propanoic acid. So now let's test your understanding of how we name carboxylic acids. Here are the first 4 carboxylic acids we'd like you to have a go at naming. So pause the video, have a go at naming them, and then we'll go for the answers. So now let's go through how we name the first 4 carboxylic acids. So the first carboxylic acid is a 3-carbon carboxylic acid, and a 3-carbon alkane is called propane. So a 3-carbon carboxylic acid is called propanoic acid. And for B, we have a 6-carbon carboxylic acid. So a 6-carbon alkane is hexane. So the corresponding carboxylic acid is hexanoic acid. Now for C, we have a 2-carbon carboxylic acid, and on carbon 2 we have a chlorine instead of a hydrogen, and we call this 2-chloroethanoic acid. Now the reason the chlorine's on carbon 2 is that the COOH carbon is carbon 1. Now for D, we have a 4-carbon carboxylic acid, and we have a CH3 group on carbon 2. So this compound is called 2-methyl butanoic acid. So here are the next 4 carboxylic acids we'd like to have a go at naming. So once again, pause the video, have a go at naming them, and then we'll go for the answers. So now let's go through how we name the next 4 carboxylic acids. So compound E has 5 carbons in the longest chain, so it's going to be pentanoic acid. And if we number the chain so that the C double bond O is carbon 1, we have a bromine on carbon 5, and we have 2 chlorines on carbons 2 and 4. So this compound is called 5-bromo 2,4-dichloro-pentanoic acid. Now if we look at compound F, we have 6 carbons in the longest chain, so the carboxylic acid is going to be hexanoic acid. If we number the carbons so that the C double bond O is carbon 1, we have a chlorine on carbon 2, and we have a CH3 group, a methyl group on carbon 5. We put the substituents in alphabetical order, so it would be 2-chloro 5-methyl hexanoic acid. And if I look at compound G, this is an aromatic carboxylic acid. We have a benzene ring and a C double bond OH. Now we can either call this benzoic acid or benzene carboxylic acid. Either is fine. And for compound H, we have 3 carbons in the longest chain. So this is propanoic acid, and on carbons 2 and 3 we have bromines. So this is 2,3-dibromo-propanoic acid. Now in the next section of this video, we're going to look at the different ways we can prepare carboxylic acids. Now our first method is from primary alcohols or aldehydes. And if we oxidize a primary alcohol partially, we get an aldehyde. And if we oxidize it fully, we get a carboxylic acid. And on this slide we have ethanol. Now ethanol is a primary alcohol because the carbon next to the OH group has 1 alkyl group attached. And when we partially oxidize it, we get the aldehyde ethanal. And when we fully oxidize it, we get the carboxylic acid ethanoic acid. Now to oxidize a primary alcohol or an aldehyde, we need an oxidizing agent. And an example of an oxidizing agent we could use is acidified potassium dichromate. And this oxidizing agent is acidified with dilute sulfuric acid. And if you gently heat a primary alcohol with acidified potassium dichromate, you will get an aldehyde. And if you reflux either the aldehyde or the primary alcohol with excess acidified potassium dichromate, you will get the carboxylic acid. Now acidified potassium dichromate is a mild oxidizing agent. And an alternative to using acidified potassium dichromate is to use acidified potassium permanganate or potassium manganate 7. Now, this is a much stronger oxidizing agent, and if you reflux a primary alcohol with acidified potassium permanganate, you will get a carboxylic acid with no aldehyde being formed. Likewise, you can reflux an aldehyde with acidified potassium permanganate to get the carboxylic acid. Now the second way to make a carboxylic acid is to hydrolyze a nitrile. Now hydrolysis reactions are reactions where we break bonds by the action of water. And nitriles are compounds that contain a carbon triple bond nitrogen functional group. And nitriles can be converted to carboxylic acids by acid catalyzed hydrolysis. To carry out an acid catalyzed hydrolysis, you just need to reflux a compound with dilute acid. For example, sulfuric acid or hydrochloric acid would work well. Now, I've drawn here 2-hydroxypropane nitrile, and when you reflux this compound with dilute sulfuric acid, the CN changes to a COOH group. And that's what happens when you carry out acid catalyzed hydrolysis. You convert a CN into a COOH. Now, the compound that's formed after this hydrolysis is 2-hydroxypropanoic acid, and that's commonly known as lactic acid. And as I mentioned previously, I could use hydrochloric acid instead of sulfuric acid, and I would get exactly the same result. Now, an alternative to acid catalyzed hydrolysis is to carry out the hydrolysis reaction in alkaline conditions, and this is called base catalyzed hydrolysis. And on this slide we have propane nitrile, and if we carry out an acid catalyzed hydrolysis, we end up with propanoic acid, and we carry this out by heating or refluxing the nitrile with dilute acid, so for example dilute sulfuric acid. And if we carry out the same hydrolysis reaction but in alkaline conditions, so heating it with dilute sodium hydroxide, we end up with the salt of the carboxylic acid. So we'd end up here with sodium propanoate. Now, sodium propanoate is CH3, CH2, C double bond O, ONA. And you can either write it as ONA at the end, or you can write it as O minus Na plus. And chemists will often write it like that to show the ionic bond that's present between the Na plus ion and the carboxylate ion. Now, to convert the salt of the carboxylic acid to the carboxylic acid, all you have to do is add dilute acid. So if you add, for example, dilute HCl or dilute sulfuric acid, you will get the carboxylic acid from the salt. Now, this means there's two different ways to convert a nitrile to a carboxylic acid. You can either heat it with dilute acid or reflux it with dilute acid to form the COOH group, or you can heat it with dilute NaOH, dilute alkali, and you will get the salt of the carboxylic acid, and then you can acidify this to produce the carboxylic acid. So now let's test your understanding of what we've discussed so far with some practice questions. Once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So now let's go for the answers to these first two practice questions. So question 1 is asking you to name the reagents and conditions required to change ethanol to ethanoic acid. So you could either use acidified potassium dichromate and reflux the ethanol with excess acidified potassium dichromate, or you could reflux it with acidified potassium permanganate or potassium manganate 7. And if you said reflux, there's 1 mark, and if you said acidified potassium dichromate or acidified potassium permanganate, there's a 2nd mark. And for part B, it's asking you to describe what you would see happening during the reaction. So if you said you were going to heat it up or reflux it with potassium dichromate, the solution would go orange to green, 1 mark for that. Now if you said potassium permanganate, the colour changes purple to colourless. So there's 1 mark for the colour change here. And for question 2, it's asking you to draw the full structural formula of the carboxylic acids formed from the oxidation of propan-1-ol and pentanal. Well, propan-1-ol is oxidized to propanoic acid, and pentanal is oxidized to pentanoic acid. And I've drawn the full structural formula of both compounds here, 1 mark for each. So here's question 3. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So question 3a is asking you to name the following compounds, X and Y. Now X is a nitrile, it's got 3 carbons in it, so it's going to be propane nitrile, and carbon 1 is the C triple bond N. So therefore the NH2 group is on carbon 3. So this compound is called 3-amino-propane nitrile. We'll mark for that. And Y is named very similarly. So we have a carboxylic acid, and the carbon 1 is a C double bond O. So it's a 3-carbon carboxylic acid, so it's propanoic acid, and the NH2 group is on carbon 3, so this is 3-amino-propanoic acid. And then question B is asking you to state the reagents and conditions needed to convert X into Y. Well, to convert a nitrile to a carboxylic acid, I need to reflux it with dilute acid such as sulfuric or hydrochloric. Now, a third way of making a carboxylic acid is to hydrolyze an ester. Now, esters have the following general formula: R, C double bond O, O, R, where R is an alkyl group, and the alkyl groups can be the same or different. Now, hydrolysis of an ester can be once again acid catalyzed hydrolysis or base catalyzed hydrolysis, just as we had with nitriles. Now, if we're going to carry out acid catalyzed hydrolysis, all you need to do is to heat the ester with excess dilute acid, and this acid could be hydrochloric acid or sulfuric acid, and you will get the following reaction. Now, the ester reacts with water in the dilute acid to form a carboxylic acid and an alcohol, and the alcohol is represented here in the equation with the formula ROH. So to help you understand what's happening here, I've drawn water as HOH, and you can see that a hydrogen from water joins with the oxygen and the alkyl group on the ester to form your alcohol, and the OH from water joins on to the C double bond O to make the carboxylic acid. Now, acid catalyzed hydrolysis is slow and reversible, so the better way of carrying out a hydrolysis of an ester is to use base catalyzed hydrolysis. Now, in base catalyzed hydrolysis of an ester, you heat the ester with dilute sodium hydroxide and you form the salt of the carboxylic acid. And on cooling, you add aqueous dilute acid, for example hydrochloric acid or sulfuric acid, and you form the carboxylic acid. Now, even though this is 2 steps, it's actually quicker and more effective than acid catalyzed hydrolysis. So these 2 equations represent the 2 steps taking place. So first of all, the ester reacts with sodium hydroxide, it forms a salt to the carboxylic acid and an alcohol, and then the salt of the carboxylic acid can be acidified either with hydrochloric acid or sulfuric acid to form a carboxylic acid and a sodium salt. Now, hydrolysis of esters and nitriles give identical products. Acid catalyzed hydrolysis of both give a carboxylic acid group, and base catalyzed hydrolysis of both give a salt of a carboxylic acid that you can acidify to form a carboxylic acid. Now, a fourth way to make a carboxylic acid is to hydrolyze an acyl chloride, commonly known as an acid chloride. Now, acid chlorides readily undergo hydrolysis to form carboxylic acids, and they have the following general formula: R bonded to a C double bond O, which is also attached to a chlorine. Now, acid chlorides such as ethanol chloride react violently with water to form carboxylic acids and hydrogen chloride gas. Now, the reason they're so reactive is that the carbonyl-carbon is bonded to both an electronegative chlorine and an oxygen atom, and this means that the molecules are very susceptible to attack by nucleophiles, such as oxygen atoms in water. Now, the following equation represents what's happening when you hydrolyze an acid chloride. So if you put ethanol chloride into water, you don't need a catalyst so it doesn't need to be heated with dilute acid. Just adding water to ethanol chloride will hydrolyze the molecule, and you'll break the carbon-chlorine bond, and you'll form a carboxylic acid, ethanoic acid, and hydrogen chloride gas. Now, when writing a chemical equation, I can either draw out the molecules in full, like I've done here, or I could use shorthand. So I could write ethanol chloride as CH3COCl, and I could write ethanoic acid as CH3COOH. Now, the last way of making a carboxylic acid that we're going to discuss in this video is the preparation of aromatic carboxylic acids. Now, aromatic carboxylic acids, for example benzoic acid, can be prepared by oxidizing methyl side chains on aromatic molecules. So if I had a benzene ring with a CH3 attached, I can convert this to a carboxylic acid in an oxidation reaction. Now, oxidation is a gain of oxygen and a loss of hydrogen. And if you look at this equation, you can see that methylbenzene converting to benzoic acid involves a gain of oxygen, because benzoic acid has 2 oxygen atoms more than methylbenzene, and a loss of hydrogen, because benzoic acid has 2 hydrogens less than methylbenzene. Now, in previous lessons we've discussed the fact that aromatic compounds are quite stable due to the fact that they have a ring of delocalized pi electrons. Therefore, if you're going to oxidize methylbenzene or any alkyl benzene, you will need a powerful oxidizing agent. And the most powerful oxidizing agent that we have come across so far is potassium permanganate, or potassium manganate 7. Now, this oxidation is different to the oxidations we've discussed in previous topics, such as the oxidation of alcohols and aldehydes, because instead of having acidified conditions for this oxidation, you need alkaline conditions. So this oxidation is carried out by refluxing methylbenzene in alkaline conditions, and they use sodium carbonate to provide these alkaline conditions. Now, this will produce a salt of benzoic acid, so sodium benzoate. And if you add acid to sodium benzoate, you will produce the carboxylic acid, benzoic acid. So these equations represent the reactions that takes place. So methylbenzene oxidized with potassium permanganate mixed with sodium carbonate, the conditions of reflux, you get the salt of the carboxylic acid, sodium benzoate, and then if you acidify this sodium benzoate, you will produce benzoic acid. Now, benzoic acid is also called benzene carboxylic acid. Now, it doesn't matter whatever the length of the carbon chain on the benzene ring. So even if you don't have methylbenzene, but you add something like ethylbenzene or propylbenzene, you can still get benzoic acid via this method of oxidation. So if you oxidize ethylbenzene or propylbenzene, you will get benzoic acid if you oxidize it with KMnO4 with sodium carbonate and then acidify with dilute acid such as HCl or sulfuric acid. So now let's test your understanding of these last 3 ways to make a carboxylic acid with some practice questions. So once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. Now, question 1 is asking you to name the 2 products formed from the acid catalyzed hydrolysis of the following esters. So the first ester is methyl ethanoate. Now, methyl ethanoate is CH3COOCH3. So if you heat this with dilute acid, you will get ethanoic acid and methanol. And I've written the chemical equation to help you understand why you get those products. So methyl ethanoate is hydrolyzed with the water to form ethanoic acid, CH3COOH, and methanol. And butyl propanoate is hydrolyzed with water to form propanoic acid and butan-1-ol. And the last one is methyl pentanoate. So when you hydrolyze methyl pentanoate by heating it up with dilute acid, you will get pentanoic acid and methanol. So now have a go at questions 2 and 3. Once again, read through the questions, pause the video, have a go at them, and then we'll go for the answers. So question 2 is asking you to describe using chemical equations how ethanoic acid can be prepared from the ester ethyl ethanoate using base catalyzed hydrolysis. So I've drawn the ester ethyl ethanoate, which is CH3, C double bond O, O, CH2, CH3. And when that reacts with NaOH, you make the sodium salt of the carboxylic acid. So you make sodium ethanoate. And your other product is ethanol. Now when writing the formula of sodium ethanoate, or any sodium salt of a carboxylic acid, you could write it like this, where you put in the charges on the oxygen and the sodium, because the sodium is Na plus and the oxygen has a minus charge on it. And you can do this to show the ionic bond between them. Now, the sodium salt, sodium ethanoate, that's formed in step 1 can react with dilute acid, such as HCl, to form the carboxylic acid, ethanoic acid, and sodium chloride in this case. Now, base catalyzed hydrolysis is a lot faster than acid catalyzed hydrolysis, even though base catalyzed hydrolysis takes place in 2 steps and acid catalyzed hydrolysis takes place in 1 step. Also notice that the reactions are not reversible in base catalyzed hydrolysis. So now let's go through question 3. Question 3 is asking you to write word and chemical equations to describe the reaction of propanol chloride with water. So propanol chloride plus water makes propanoic acid and hydrogen chloride gas. So the chemical equation would be CH3CH2COCl plus H2O makes CH3CH2COOH plus HCl. And I could write it in shorthand formula like I've done here, or I could draw the full structural formula to show this equation. So here's our last practice question for you to have a go at. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So question 4 is asking you to give the reagents and conditions required for this oxidation reaction. And they tell you that this reaction is undertaken the same way as the oxidation of methylbenzene to form benzene carboxylic acid, which is commonly known as benzoic acid. Now, to carry out this reaction, you need to reflux the compound with alkaline potassium permanganate. And they normally use sodium carbonate to produce these alkaline conditions. Now, after refluxing it with alkaline potassium permanganate, you then acidify with dilute acid. Now, there's one mark if you mention potassium permanganate and one other point from this list. So in other words, heat or alkaline conditions. And if you had all the conditions mentioned here, so in other words, heat or reflux with alkaline potassium permanganate and then acidifying, you get the 2 marks. So that concludes this video lesson. So after watching this video, you should now be able to recognize a carboxylic acid functional group in a molecule and be able to name carboxylic acids using the IUPAC system. You should be able to describe how carboxylic acids can be prepared from primary alcohols, aldehydes, nitriles, esters, and acid chlorides. And you should be able to explain how benzoic acid can be prepared from methylbenzene in an alkaline oxidation reaction. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @Radachemistry.